Hi, this is Daniel Wang from Mr. Haps Period 1 Calc BC class. Today I'm going to be doing um, Calc BC 2000 FRQ number 3. So the question reads, the Taylor series about x equals 5 for a certain function f converges to f of x for all x in the interval of convergence. The nth derivative of f at x equals 5 is given by f to the n of 5 equals negative 1 to the n times n factorial all over quantity 2 to the n times n plus 2, and f of 5 equals 1/2. Okay, so part A asks to write the third degree Taylor polynomial for f about x equals 5. So we should remember that the formula for a Taylor polynomial is going to be f to the n, so the nth derivative of x times x minus a to the n all over n factorial. So a is going to be equal to 5, so we have a equals 5, and we have f to the n of x from the problem, which is right here. So this is going to end up looking like f of 5 plus f prime of 5 times x plus f double prime, oops, sorry, let me rewrite that, f of 5 plus f prime of 5 times x minus 5, so that's that x minus a term, plus f double prime of 5 times x minus 5 squared all over 2, plus f triple prime of 5 times, x minus 5 cubed all over 6. I know you can't see that, but it's pretty straightforward. So, what's our f of 5? Well, that's going to be 1/2. What's f prime of 5? Well, we have from right here that f, the first derivative at 5, is going to be negative 1 to the 1 times 1 factorial over 2 to the 1 times 1 plus 2. So we have that times x minus 5 plus, oops, our second derivative, which is going to be negative 1 squared times 2 factorial over 2 squared times 2 plus 2. That times x minus 5 squared over 2, and then we're going to add that to f triple prime of 5, which we should know is negative 1 cubed times 3 factorial all over 2 cubed times 3 plus 2 times x minus 5 cubed over 6. Okay, so this is going to give us 1/2 plus negative 1 over 6 times x minus 5 plus 2 over 4 times 4 times 2 times x minus 5 squared plus negative 6 over 8 times 5 times 6 times x minus 5 cubed, which is going to give us 1/2 minus 1/6 times x minus 5 plus 1/16 times x minus 5 squared minus 1/40 times x minus 5 cubed. Okay, so that's going to be our answer for number 1. Okay, number 2 asks to find the radius of convergence of this Taylor series. So let's go to the back. That's pretty easy too. So remember that our Taylor series is going to be the sum from n equals 0 to infinity of our nth derivative. Let's just write that down. So that's negative 1 to the n times n factorial over 2 to the n times n plus 2. So this is our series. And then we're going to multiply that by 1 over n factorial, multiply that by x minus 5 to the n. So immediately we see that these cancel, so we're left with something that looks like this. Okay, so we have two options. We can use the ratio test or we can use the root test. The root test actually looks easier, but we'll go ahead and use the ratio test. Remember that we're dealing with absolute values, so this term doesn't really matter. So we end up with this. Remember, we're just replacing all the n's with n plus 1s, and then we divide by the original sequence, or the series rather, and this yields x minus 5 over 2 times n plus 2 over n plus 3. But remember, this is the limit, so this is the limit as n approaches infinity, so this yields x minus 5 over 2. And the absolute value of this is going to be less than 1. So it's pretty clear from here that our radius is going to be 2. Part C asks us to show that the 6th degree Taylor polynomial for f about x equals 5 approximates f of 6 with error less than 1 over 1000. So this is pretty straightforward application of our alternating series error remainder theorem, or whatever it's called. So we want to show that the 6th degree Taylor polynomial has some degree of accuracy. So what we need to do is we need to show that the coefficient before the 7th term, you need to show that f of 6, the term that comes after the 6th degree term is going to be less than 1 over 1000. Therefore, it's not going to affect the sum. So what's our 6th degree Taylor polynomial? Well, it's going to go all the way up to some term with some coefficient times x minus 5 to the 6th. So we want to find the value of the 7th degree term. So that's just going to be negative 1 to the 7th times 7 factorial over 2 to the 7th times 7 plus 2 times 1 over 7 factorial times x minus 5 to the 7th. Like this. And these are going to cancel, and this is going to turn into a negative 1, so we can cross out that exponent. So we're just going to be left with negative x minus 5 to the 7th over 2 to the 7th times 9. But remember, it's the alternating series remainder error theorem, so this negative sign doesn't really matter. So we just need to show that at 6, this value is less than 1 over 1000. So if we plug in 6, this term goes away, becomes 1. So then we get 1 over 128 times 9. And let's compute that. This is going to be 1 over 1152, which is smaller than 1 over 1000. So this shows that, here, let's draw an arrow. This shows that t sub 6 of 6 is within 1 over 1152, so it must be within 1 over 1000. Okay, so I hope this helped. Thank you for watching.